Imagine coming home to a house that has already cleaned itself while you were away. For decades, this idea existed only in science fiction and futuristic imagination. But in America, engineers have been quietly turning this fantasy into working machines. A new generation of home robots is learning to sense, decide, and clean without help. These machines can now navigate rooms, avoid obstacles, and adapt to real homes. But how did engineers teach a machine to understand something as messy as a home? And what problems had to be solved before a robot could clean safely and reliably? The answer involves failed prototypes, stubborn obstacles, and unexpected breakthroughs. It also raises a bigger question about how much of our daily lives machines will eventually handle. To understand where this technology is headed, we first need to understand where it began. The dream of an automatic home cleaner is far older than most people realize. Inventors imagined self-operating cleaning devices as early as the 20th century. Early attempts were simple, clumsy, and often failed to clean anything effectively. Basic machines could push dust around, but they had no way to sense their surroundings. Without sensors or intelligence, these machines constantly bumped into furniture and walls. Engineers realized that cleaning a home required more than just motors and brushes. A true home robot would need to understand the shape and layout of its environment. In the late 1990s, American robotics teams began exploring simple mapping techniques. Early prototypes used basic bump sensors to detect walls and change direction. These robots moved randomly, cleaning through repetition rather than genuine understanding. It was inefficient, but it proved that autonomous cleaning was technically possible. The first commercial robotic vacuums reached American homes in the early 2000s. Consumers were fascinated, but the technology still had major limitations. Early robots often got stuck under furniture or tangled in cords and rugs. Battery life was short and cleaning coverage was inconsistent at best. Despite the flaws, these early machines proved there was real public demand. Engineers saw an opportunity to build something far smarter and more capable. The next challenge was giving robots a genuine sense of spatial awareness. This meant developing sensors that could detect distance, depth, and obstacles in real time. That single breakthrough would change the direction of home robotics forever. Modern home cleaning robots rely on a combination of sensors working together. Many use laser distance sensors, known as LiDAR, to map a room accurately. This technology sends out laser pulses and measures how long they take to return. From these measurements, the robot builds a detailed digital map of its environment. Cameras add another layer of understanding, helping the robot recognize objects and obstacles. Some robots use infrared sensors to detect drop-offs like stairs or ledges. This prevents the machine from falling and causing damage to itself. Once the robot has a map, it can plan efficient cleaning paths. Instead of moving randomly, it can clean row by row, like mowing a lawn. This approach dramatically improves both speed and coverage across a home. Underneath the sensors, a small onboard computer processes information constantly. This computer decides where to go, when to turn, and how to avoid obstacles. Artificial intelligence software helps the robot recognize different types of flooring. It can then adjust suction power depending on whether it is on tile or carpet. Some robots are being developed to identify specific objects, like shoes or cables. Recognizing these objects allows the robot to avoid getting stuck or causing damage. Motors, brushes, and vacuum systems work together to physically remove dirt and debris. Meanwhile, wireless connectivity allows the robot to communicate with a smartphone app. Through this app, homeowners can schedule cleanings or view a map of their home. Every part of this system depends on components working together in real time. For years, home robots could clean, but they could not truly understand a home. The real breakthrough came when engineers combined mapping with artificial intelligence. Instead of simply avoiding obstacles, robots began learning to recognize different rooms. This allowed users to send the robot directly to a kitchen or bedroom. American robotics companies began training these systems using massive amounts of sensor data. Machine learning models were exposed to thousands of home layouts and furniture types. Over time, the software became better at predicting where obstacles were likely to appear. Engineers also improved how robots handle uncertainty in unfamiliar environments. If a robot encountered something unexpected, it could now pause and reassess safely. This made the technology far more reliable in real, unpredictable households. Another major improvement came through better battery and charging technology. Robots began automatically returning to charging docks when battery levels dropped. Some systems were developed to empty their own dustbins into a larger base station. This reduced the need for constant human involvement in the cleaning process. Voice assistant integration allowed users to start cleaning with a simple spoken command. Engineers also began testing robots that could clean multiple types of surfaces. This included switching between vacuuming and light mopping in a single session. Each of these upgrades solved a specific frustration reported by real users. Together, they transformed the home robot from a novelty into a genuine tool. But even with these advances, a bigger question remained unanswered. How exactly is this technology changing the way people actually live? For many households, automatic cleaning robots have reduced daily manual cleaning time. Families with young children have reported fewer worries about crumbs and small messes. Pet owners have found the technology especially useful for managing shedding and fur. Older adults and people with mobility challenges may benefit significantly from this technology. Reduced physical strain from cleaning tasks can improve quality of life for some users. Beyond individual homes, this technology has influenced the broader home appliance industry. Competition between American robotics companies has driven rapid innovation and lower prices. As prices dropped, robotic cleaners became accessible to a much wider range of households. This shift has encouraged even more investment in home robotics research. Some companies have begun exploring robots designed for other household tasks entirely. This includes early experiments with robots that assist with organizing or tidying spaces. Smart home integration has also expanded, connecting cleaning robots to other devices. Homeowners can now link robots with smart locks, lighting, and security systems. This creates a more automated home experience beyond just cleaning alone. Economically, this growing industry has created new engineering and manufacturing jobs. American technology hubs have become centers for robotics research and development. Universities have expanded robotics programs to meet rising industry demand. Still, experts note the technology is far from replacing all forms of manual cleaning. Deep cleaning tasks still typically require human effort and attention. Despite this progress, home cleaning robots still face serious technical challenges. Complex or cluttered environments remain difficult for even advanced robots to navigate. Thick carpets, loose wires, and small objects can still cause the robot to malfunction. Stairs remain a major limitation, since most robots cannot safely climb them. This means multi-level homes often require more than one robotic unit. Battery capacity continues to limit how much a single robot can clean per session. Larger homes may require multiple charging cycles to complete a full cleaning task. Cost remains another significant barrier for many potential buyers. Advanced models with mapping and self-emptying features are often expensive. This price gap creates unequal access to the most capable versions of this technology. Privacy concerns have also emerged as robots collect detailed maps of people's homes. Companies must carefully manage how this sensitive data is stored and protected. Security researchers have warned that connected devices can sometimes be vulnerable to hacking. Engineers continue working to strengthen data protection within these smart systems. Mechanical wear is another challenge, since brushes and motors degrade over time. Repair and replacement costs can add up over a robot's lifespan. Some users report frustration when robots get stuck in unexpected situations. Software errors can occasionally cause robots to clean inefficient or repetitive paths. Engineers are continuously updating software to fix these performance issues. These challenges show that perfecting home robotics is an ongoing, difficult process. So, what comes next for automatic home cleaning robots in America? Researchers are exploring robots capable of climbing stairs safely in the future. This could eventually allow a single robot to clean an entire multi-level home. Engineers are also testing more advanced object recognition systems using deeper AI models. These systems may allow robots to sort or organize small items during cleaning. Some companies are researching robotic arms that could work alongside cleaning units. This combination could eventually make robots capable of picking up and moving objects. Battery technology improvements may allow future robots to clean for much longer periods. Faster charging systems could also reduce downtime between cleaning sessions. Researchers are exploring ways for robots to communicate and share environmental data. Multiple robots working together could potentially clean large homes more efficiently. Artificial intelligence may eventually allow robots to learn individual household habits. This could help robots anticipate cleaning needs before a mess even happens. Some engineers are exploring robots that assist with light home maintenance tasks. This may include tasks like watering plants or adjusting home temperature settings. However, experts caution that full home automation remains a long-term goal. Ethical and safety questions must be carefully addressed as robots become more capable. Researchers continue studying how much independence a home robot should safely have. This balance between convenience and safety will shape future development decisions. What seems certain is that this technology will continue evolving rapidly. From simple bumping machines to intelligent mapping systems, the journey has been remarkable. American engineers turned a science fiction dream into an everyday household tool. Yet this story is still being written, one breakthrough at a time. Each new sensor, algorithm, and design brings robots closer to true home assistance. The question is no longer whether robots can clean our homes. The real question is how much more they may eventually be trusted to do. As artificial intelligence advances, robots may take on responsibilities we cannot yet imagine. This raises a deeper question about the balance between convenience and control. How much of our daily lives are we willing to hand over to machines? That answer may define not just our homes, but the future of daily life itself.